Good day, guys. How is everyone doing? So, my name is Ibrahim Suleiman, and I want to talk to us about building games, right? Building fully on-chain games on Starknet using Dojo engine, right? So, in the next couple of hours, we'll be exploring the Dojo ecosystem. We'll be exploring the various tools in the Dojo ecosystem as well, and we'll also learn how to, build, test, and also deploy our Dojo contracts on Starknet. So let's jump right in. So the first thing we are going to be talking about is Dojo engine. So what is Dojo engine? Dojo engine is a framework for building provable on-chain games on Starknet. So if you have maybe a game idea and you want to bring it on-chain, right? You want to build a fully on-chain game. You want to build a fully on-chain game, right? Dojo engine is your go-to ecosystem, is your go-to tool for building fully on-chain games on Starknet. So the next thing we'll talk about is Dojo engine provides a suite of tools, right, that speeds up the process of developing and iterating on your on-chain games. So if you've played any on-chain game, right, maybe on Starknet or any other blockchain, right, you notice, especially on Starknet, let's talk about Starknet now, right? If you've played the games on Starknet recently, right, you notice the experience, right, seems more like a Web2 experience. And why is that? It's because of Dojo engine and, cartridge ecosystem as a whole. I'll talk about cartridge later on, right? So that experience that you get from playing, right, that's cool experience that you get from playing a fully on-chain game on Starknet, right, is being powered by the Dojo engine, right? So let's talk a little bit about the Dojo ecosystem as a whole, right? For instance, if you have a Dojo project, right? Now, the first thing that I want you to know about is a resource, right? A resource is any model or system that can be registered in the world, right? Now, I might be using a lot of new terminologies to you, right? Because those terminologies are specific to fully on-chain games, autonomous world, right? But if you don't understand any at any point in time, just call my attention and I'll be super happy to go back and explain it to you, right? So a resource now, right, is any model or system that can be registered in a world, right? Now there are three new terminologies here, right? When it comes to the fully on-chain game space, I mentioned model, I mentioned system, and I mentioned world, right? So I'll be explaining all of those terminologies shortly, right? But from your end now, just know that a resource is any system model that you can register in a world. Now, talking about world, right? Your world is a contract that stores all your models and systems, right? Now, for a regular Web2 game, right, you have a backend server, you have a database, and in that server lives the logic of that game, right, of that game you're playing, right? So that is somewhat similar to what we have, right, in a fully on-chain game using Dojo engine. Now, in this case, your world, right, is that single contract that stores all of your models and your system, right? Your systems are your logic, right, your game logic, and your models are the structure of data that is to be stored in your world, right? So just think of it this way: your world is a contract, right? Is your game contract, right? All together. Just like how you build a backend server for your game and you deploy it somewhere and get a link to that server, right? And in that server is where all of your that server access and modify your database, and also determines what gets sent to the client, right? So that is the equivalent of a Dojo world. It's just like it's a contract, because we are building on-chain games, right? So a world is a contract, right, that stores all of your models and system. And a model, right, defines the structure of data stored in your world, right? Model is, I think the closest thing I can relate to a model now is your schema, your database schema. If you have a database and you want to store data in that particular database, you need to create a schema, right, or collection, right, that tells the database how to store that particular data, right? So that is similar to what a model is, right? A model defines the structure, right, of data. So it tells your contract the type of data that is to be stored in it, right? And the system, right, is a system is basically a function, right? Let's say your system now, right, contains your game logic, right? All of the business logic and everything, right, that involves state change in your game. That is what your system is, right? And looking at it from the perspective of a contract, right, your system is basically a set of contract functions that alter the world state, right? I talked about the world being right, a contract that stores all of your models and your system. So if you want to alter that world state, if you want to alter your game contract, right, you'll have to define those logic and rules in your system. So are we together? Talked about resource, talked about world, talked about model, talked about system. Right, so at this point, is there any question before I proceed? Now, this is not, let me give a very simple analogy, but this is not like an equivalent of that. It's not like a direct equivalent, right? But just take your models, right, as your database schema. For instance, MySQL database, right? You have a schema, right, that defines how to store data in your database. Take your model as a schema. Take your system as your backend logic, right? If you are building your API with JavaScript, Java, Python, the logic you write, right, for your REST API endpoint, for instance, right? Those logic, right, are the equivalent of what is in your system. Are we together? Is there any question at this point? So now, talking about the Dojo world, right? The Dojo world, as I said earlier on, right, it stores all of your game states in one contract, right? So the thing about fully on-chain games is the fact that all of your data is stored on-chain, right? All of your data is being stored on-chain, which means it is immutable. So the benefit that this provides to not just you as a builder, but to the players, is the fact that every gameplay, every item, every action you perform on that game lives forever, right? In the conventional gaming space, there is a lot of restriction, geofencing, right? Your friends in other countries might be able to access a game, but you won't be able to access it because there is no, that particular game server is not in your location. You get a lot of different problems like this. Most games shut down their server after some time. Most games reset. Most people even most games even cheat, right? Most games even cheat because, you know, they are using a regular database, so the database is easily modifiable, right? Right? Like I saw a tweet some time ago about a game, right, where you can just right from your browser, from the client side. I guess that's like an oversight from the dev team. Right from your browser, you can just, you know, modify the request it's sending to the server just to alter your score. Right? I think maybe a hacker found that loophole in a game, and, you know, people were able to like use that loophole to cheat in that particular game. Right? But such kind of things does not exist in a fully on-chain game. Why? Because you can't change the blockchain data. It's immutable, right? And the data is being secured by thousands of nodes on that blockchain network, right? On Starknet, for instance, there are thousands of you know, nodes securing the network. So you can't really, you know, go and just change the state of the game just to favor you, right? So that's the benefit of a fully on-chain game. And another thing about the Dojo world is permissions, right? You need, now the resources in your world, right? I talked about models and system, right? Now you need to like define some kind of permissions, right? On how your models will be accessed, right? Because you don't want any system or any other contracts like to just, you don't want to like open your models up for any contract to just come and modify it. You, in a Dojo project, you define permissions, right? Those permissions will tell the Dojo project, okay, which system can access this model, which system cannot access this model. And it's super easy to do it using Dojo, right? And the world also has an API, right, that you can use to read and write to your contract state. So most of the operation, right, most of the operation you most likely do is simply read and write to that contract, right? Simply read. When you read data, probably you read the data from a model, and when you write, right, let's say you create a new game or a player joins a game, you can write to that model and, you know, add that particular player's username to the model, right? So the World API provides an interface, a very simplified, like super simplified interface that you can use to read and write to your World contract. So a model, right? A model, as I said earlier on, a model, you know, defines the structure, right, of the structure of data that is to be stored in your contract, right? And models, we will see shortly, right, that models are basically Cairo structs that are annotated with Dojo model. Right, so if you have a struct and add this annotation, your struct will become a model, right? So the key requirement is all of your models must have at least one key, right? We'll see shortly why we'll need one key. And all of the keys, right, in your model, you know, I talked about your model being a struct. So all of the keys, right, all of the keys must come before any other field. So what it means is, apart from just fields, your models can have, apart from just the keys, right, of that model, your model can have other keys as well. So talking about a system Dojo contract functions with permission access. Right, as I said earlier on, they are basically functions, right, that access and modify your models. Right, they can alter the world states, but they are stateless themselves, right? And permission is required from from a system to modify a Dojo world. So this is how you define a system by using a Dojo contract, right? And for the interface, you use this annotation, Starknet interface. I will show you this in code shortly. I just want to introduce you to the Dojo ecosystem. So, talking about the components of a Dojo project, we have events, right? Events are emitted, right, once a state change happens in your contract. Let's say you modify a model, for instance, you update a model or you create a new model, right? Events are emitted automatically, right? But you can also create your own custom event, right, and emit that event inside your functions, inside the system of your functions, right? And these events are being indexed by Tori. So what it means is they'll help keep the front end of the client, or let's say the clients, right? The various clients that are connected to your app or the various users that are playing your game. This event will keep them informed about what is happening in the contract, right? Let's say a new player joins a game now, right? There's no way your client, right? There's no way another player who is waiting for other players to join, will be able to know that another player has joined the game, if not for events, right? So what will happen is, in your contract, you can just emit an event when new players join. So your client who is listening for, maybe your browser or your phone who is listening for that event, right, will simply just update the UI as soon as the event is being emitted. So that's one of the benefits of events. And metadata, we'll talk about metadata, but there are basically more details about your Dojo game, about your Dojo project, right? Just like the name, description, your social URL, and a couple of other things. Then authorization, we'll see how we can set authorization, right, in our config, in our script.toml file. And one other thing I want you to know is Dojo, right, is a profile-based system. So what does that mean, right? It's like, think of it as different environments for development. Right? Altogether, think of it as different environment for your development, right? So what it means is you have the dev profile, you have release profile, you have Sepolia, and you can have mainnet, right? So what does that mean is, it means you can run your Dojo project on basically different environments, different parameters, right? You can run it on dev, and you can also create, the default profile is actually dev, but you can actually create more profiles. So before we talk about ecosystem tools, let's quickly jump into more details, right? This is just like a summary of what we'll be doing. So let's jump into the details. So altogether, is there any question at this point? Is there any question at this point? Okay, no question, so let's move on. Yeah, so in the World API, right? In the World API, there's 3 methods that you most likely use. Like, these are the methods you mostly use in maybe 80% or 70% of your game, right? You use the read model, write model, and emit event. So read model is used to to read data from the model, right? While write model is used to update the model data, right? And emit event is used to emit event. So there are other methods in this API, but these are the ones you mostly use. So I talked about all of these. So one thing I want you to know is Dojo contracts are similar to your regular Cairo contracts, right? They are super similar. If you know how to write a Cairo contract, right, you are good to go. You are good to start writing a Dojo contract as well, right? It's just some little additions, right, that are specific to the Dojo ecosystem, but the syntax is the same. Right, the syntax is basically the same. As I say, just some little additions. So this is how you create an interface, right? You add the Starknet interface at the top. So we'll look at all of this once we start writing the code. So let's create a new project, right? So let's create a new Dojo project, right? So we can all like see, all of these components of a Dojo project, right? While I explain it. So I think that will be more visually appealing. So let's see. So the first thing to do, right, if you want to create a new Dojo project is to install the Dojo engine, right? So I already have Dojo engine installed on my laptop. So what I'm going to do is I'm going to show you the installation process on GitHub Codespace, right? Because that's like because I can't really install it again on my machine, right? It's not going to be the same process for you. So I'm going to be using GitHub Codespace, so we all start on the same ground. So after we are done with the installation, I can come back and use the local environment. So I'll create a blank code space. So before we proceed, right, before the code space comes up, if you are using Ubuntu, if you are using a Linux here and you're using Ubuntu, right, you need to be on at least 24.04 to be able to install and run the latest version of Dojo engine, right? So yeah, so if you are using Ubuntu, right, I'll say that again. If you're using Ubuntu, you need to be on at least 24.04, right? So we'll just wait for this to come up. But if you want to go ahead and, you know, start installing it yourself, let me just take this here. But if you want to install it yourself, you can go to Dojo engine, go to the documentation, and click on, click on quick start. So these are the steps, right? But if you don't have Rust installed, you need to install Rust. You have to run Dojo locally. So the first thing to do is to install Rust and install Scab, and then you install Dojo up. Dojo up will now activate Sozo and Tori, Katana, and all of the CLI tools that you need. So are we all together? Are we all on this page? I don't go to dojoengine.org and click on installation. You see a link that says get started, so click on the link. Okay, so CodeSpace is taking a little while. Let me see if it's fully up. Okay, CodeSpace is fully up. So what I'm going to do now, right, is to, because CodeSpace, right, by default, it doesn't comes with Ubuntu 24.04. So I'm going to configure this CodeSpace to use Ubuntu 24.04. So let me quickly pull out this guide. So there's a guide I wrote about configuring CodeSpace. I'll also share a link to this guide in case you are interested in using Ubuntu to run your setup. To use GitHub CodeSpace to run your setup. All right, so first thing to do is to create a folder called dev container. So these are like the prerequisite instructions. So let's quickly do that. So after creating dev container.json, you simply paste this JSON config inside your code space, inside our dev container.json. So let's quickly do that. Let me confirm. So the next thing is to reload this code space. It's to rebuild the container. Let's do a full rebuild of this container. So it's trying to reconnect code space. So let me rebuild this container from scratch. I don't know, my code space is not really responding as expected. So let me just reload this window. I'm expecting to see all of the files are being saved automatically. So Yeah, this is what I was waiting for. So I'll just rebuild this code space, and when it's done rebuilding, it will give me Ubuntu 24.04, right, which will enable me run the latest version of Dojo engine. Well, I believe the documentation is pretty easy to follow. I don't know, I think code space is kind of overloaded at this point in time, and it's not responding. But from your end, if you want to install it locally, right, the first thing to do is to install Rust. And if you want to install Rust, you go to the Rust documentation, this particular part of the documentation. You copy the installation command, right? So after copying it, you paste it in your terminal, and it will take some time and install Rust for you. The next thing to do, right, is to install Scarp. So you click on this link here, it will take you to the Scarp installation page. This is not up. Okay, so let's just continue, pending when it comes up. So this particular link here will take you to the Scarp installation page. Okay, this is the Scarp installation page. So what you should do, right, is to install Dojo, is to install Scarp 2.9.4, right, because the latest version of Dojo, right, requires 2.9.4. So if you are installing, or you might be installing Scarp, right, using the installation script, all you have to do is to come over here, instead of 2.11.4 over here, right, you change it to 2.9.4, right? So that will give you access to Scarp 2.9.4, and with Rust and Scarp, it means you're good to install Dojo, right? So the next thing to do is to install Dojo Up, and Dojo Up is a CLI. Dojo Up basically helps you to install the set of tools, right, in the Dojo ecosystem, right, in your terminal. Right, so what Dojo Up will do is when you run it, it will install Tori, it will install Sozo, it will install Katana for you. All right, I'll talk about what Sozo, Tori, and Katana do, right, shortly. But just know that when you run Dojo Up, it will install those tools for you. And this is how you install Dojo Up and get access to it directly from your terminal. So after you copy this command, paste it, and run it in your terminal, you get access to Dojo Up. The next thing you do is you run Dojo Up. That will install, that will like set you up for development using Dojo engine, right, all together. So that is exactly what I did, right, in order for me to have access to Dojo, right, from my terminal. So I can simply check the version of Dojo I have, right, using Sozo -- version. So as you can see, I have the latest version of Dojo installed. From Sozo, you can see that it's 1.4.2. I can do the same for Tori. The same 1.4.2, same for Katana. 1.4.2. Right, so those are the steps that you take in order to get access to these tools that I have locally. All right. Yeah, you can use ASDF, sure. You can use ASDF, but just follow the command here, the setup instructions here. That's if you already have ASDF installed. But if you don't have ASDF installed, you can check out the ASDF official guide on how to install and set it up on your machine. So this is the ASDF guide. You can check it out. And the guide is pretty much comprehensive in guiding you, depending on which terminal you're using, right? So at this point, are we on the same page? I think our code space is probably overloaded. It's not responding. But probably before the end of the class, I'll still try it out, just like show the installation process. So have we all installed Dojo engine locally? Because that's what we'll be moving to in the next step. We'll be using Sozo to create a new project. Is there anybody who has not installed Dojo engine? Okay, what's the problem? What? What's the problem? I didn't get you. No, just go to dojoengine.org. But I will share links to the resource right after the class. But just go to dojoengine.org and you see it. If you go to dojoengine.org, click on documentation, click on installation, then click on quick start. Are we together? So who else has not installed Dojo engine? We've all installed it, right? We are good to go. Okay, so let's proceed to create a new project. So before we create a new project, let me tell you a little bit about tools in the Dojo ecosystem, right? And you'll see how we'll use this tool shortly. Right, the first one is Katana. Right, Katana is a blazingly super fast Starknet sequencer. So Katana is like you having access to the Starknet blockchain locally, right? Okay, I thought there's a mistake. So Katana is like you having access to the Starknet blockchain locally, and the advantage of that is the fact that you'll be able to like speed up your development process. So if you make any change to your contract, you can easily deploy within seconds and test out that contract locally from your computer. And you can also, connect your client, right, to Katana, right? So that is where you have these Starknet JSON RPC support, which means that you can connect just like how you connect your client to RPC providers, right? Just like how you get link and API access to RPC provider. When developing locally, you can easily use Katana for all of that. Right? We have cross-layer communication. You can use Katana to communicate with. Okay, is there a question? Okay. Yeah, you have a lot of other benefits of using Katana. Super efficient and super good to use. So the next tool I'll be talking about is Sozo. Now Sozo is like your all-in-one tool for managing your Dojo project, right? Sozo is a CLI tool, right? So it allows you to manage your Dojo project, right, locally. Right, so what does that mean? It means you can build your Dojo project, you can deploy, right, which is migration. When you migrate in Dojo is similar to how you deploy, right? How you deploy a regular contract, right? You can use it to even generate bindings, right, for your front end, right? You can generate some TypeScript bindings that your clients can use to interact with your contract. So your client can be aware of the functions in your contract and interact with that contract using the bindings. You can do a lot of cool stuff with Sozo. So the next tool is Tori. Tori is an indexer, right, for your Dojo world. So as soon as you deploy your Dojo contracts, right, you can use Tori to index that particular contract using the address. So what it means is whenever a state change happens, right, in your contract, Tori keeps track of that, and Tori also sends that if you set your client to listen to events emitted, right, in your contract, Tori, right, is that guy that will send that event to your client immediately it's emitted in your contract. Tori also indexes your word data as well. So Slot, right? Slot is a tool chain developed by Cartridge, right, for rapidly spinning up Katana and Tori instances for play testing of your games, right? You know, maybe you have like teams that are not in the same location, or you're done building your game and you don't want to deploy to either testnet or mainnet because you're still in active development, right? Slot, right, is that guy that comes and rescues you. So what it does is gives you access to Slot allows you to deploy your contract to a Katana instance, and it also gives you a Tori instance, all of which can be accessed from your front end, right? So it's like after you're done building your game, like your game was in localhost, you know, all the while, and you're done building, you want to like quickly share it with friends, you want to share it with maybe other developers, right? You just want them to get access to that game out of your computer. So Slot is like your escape out of localhost, right? Gives you both Katana and Tori instance that allows you to interact with your game from anywhere. So the next thing we'll be doing now is to create a new project. So in order to create a new project, you can use the command sozo init, then name that particular project whatever you want, right? You can name it my Dojo. Let me just call it my first Dojo game. But you can name it whatever you want, right? And also you can see a list of all of the commands that you can run, right, in Sozo. If you check the reference, so when you come here, you look at the reference, you can see a lot of all the commands that you can run with Sozo. So just check it out. So let's create a new game. So as you can see, I just created a new Dojo game. So basically what happened was this particular command that I just ran generated a boilerplate for me, a boilerplate that I can use to start building my game. Just like for people that do front end, your create React app, how it generates boilerplate for you, or maybe your HouseCab, right, generates, you know, boilerplate for you for new project. So that is equivalent to what I just did. So let me open that folder up, my first Dojo game. So as you can see, this is the folder structure, right? This is the basic folder structure of a Dojo project, right? And the first thing I want us to check is the scrap.toml. So the scrap.toml is where we basically add packages, dependencies, and other configuration for our project, right? So the first thing that I want you to take note of in this project is this particular name, right? This is the name of your project. Is super important, right? It's super important. And this is what will be used when we start talking about namespace. This is what will be used to create a namespace for this particular project. So these are just list of commands, and also take note of the Cairo version. So this is very important, right, when you're developing with Dojo, because Dojo moves very fast, right? They release newer version of Dojo engine frequently. So what does that mean? It means you most likely be updating your project version, the version of Dojo your project is using, frequently as well. So in order to do that, right, the first thing you should note is this particular version, right? These two guys here, this guy and this version here. The first thing you should note is they must be the same, right? They must be the same. And secondly, if you want to use a specific version of Dojo engine, you must ensure that it is supported by the version of Cairo you have installed, right? Like Dojo 1.3, I think 1.3, right, doesn't support Cairo 2.4. So in this case now you're using 1.4. Let's say you want to maybe downgrade to 1.3. Now 1.3 will not work with Cairo 2.9.4 because what Dojo 1.3 is expecting Cairo 2.9.2. So you should take note of these things before you change your Dojo, the Dojo version your project is running on. Make sure you check for the version of Cairo that particular Dojo version is compatible with. And also, yeah, this particular one, they must be the same. So let me just revert it back to 1.4. So let's dive into this project that was created for us. So the first file that I want us to check out is the lib.cairo, right? So lib.cairo, is there a question? So from your lib.cairo, you can see how your project is being organized, right? You can see that you have the tests, you have models, and you have systems, just like the models and systems we talked about earlier on, right? So let's quickly open our models to see. Now, if you look at this model, right, you'll notice that the first model we have over here is the moves model. And in this moves model, right, there is the player, there's remaining last direction and can move. These are all keys, right? These are all like fields in this model, right? And if you notice one thing, this is a struct. This is a Cairo struct. So if you know how to write struct in Cairo, it means you can easily write a Dojo model, right? So that is what this means, and the only difference is just this particular notation here when you see Dojo model. So this is what will tell Dojo engine that this is a Dojo model. So this is the key of this model. Now let's go back to that comprehensive note that we were looking at earlier on. Let's go back to model. So over here, I said a model defines the structure of your data to be stored in your world. Now models are Cairo struct, right? Annotated with this Dojo model. Now one important thing you should note is all models must have at least one key, right? Like in our case now, this moves model has the player field as the key. So every model you are defining, right, must have at least one key. But another thing you should notice, models can have more than one keys, right? So what does that mean? Right, you can have, you can say key, you can add this remaining field here, this field named remaining, as the second key to your model. What does that mean? It means if you want to access this model, you need to provide both keys. So let me take that off. So the key attribute in a model, right, indicates which field is used to index and identify the storage location of a model. So your key is like in a database, for instance, that particular, let's say, that particular ID you use to query for that for a particular row in your database. That's the equivalent of a model, right? So a model is used to, a model key, right, is used to index and identify the storage location of a model. So another thing you should notice, all keys, right, come before any other fields in the model struct. So just as you can see over here, the key came first. So what it means is we can't have something like this. What it means is we can't have something like this, right? We can't have something, we can't have a key after a field. Right? All keys must come first. So this is how you create your model, right? You create a Cairo struct and you add the keys over here. For instance, if you look at player is of type contract address, and remaining is of U8, last direction is an option direction, and can move is a Boolean field. So you can do the same. As you can see, this is another model, right? Directions are available. You have players, you have directions. This is also another model, right? Because of this name position, and this is an enum, right? This is not a model, this is an enum. So as you can see, this particular enum is being used inside the model, right? Okay, vec2 is a type that we created. Let me see if I can, yeah. Vec2 is a struct. It's a custom struct. So what does that mean? It means you can store custom structs. So it means you can store custom structs in your model. And it also means you can store array in your model, right? So let's go back to the note and, okay, at this point, is there any question about Dojo models? Do you have any question about models? So I have a question. So my question is, can we have more than two keys in a model? Can we? Okay, that's correct. We can have more than two keys in a model, right? But the keys, right, must come before, right, any other field. And if you want to query that particular model, you need to provide those keys as well. So let's move on to actions. So before I conclude on models, so this is how you create as many models as you want, right? You can basically use these models to define the structure of your data, right? To be stored in your world, in your Dojo world, in your Dojo contracts, whichever. So let's move on to actions. And just as I said earlier on, actions are like the logic, think of business logic of your app, right, of your game in this case, right? So the first thing I want you to know here is actions have interface. They are like Cairo, they are like Starknet contracts that you are used to, right? Just as I said earlier on, they're like if you're already used to Cairo programs or Starknet contract, you should find it very easy to follow along and build the Dojo engine. So actions are like your regular contract once you've been writing, but with a little bit of with some little twist, right? But I'll just talk about the similarities first before I talk about the twist. Now you can see that there's an interface here. Just like your regular Starknet contract where you have interface, you also have interface in your actions, right? And similarly, you can create the functions, right, in that interface, just as you do on a normal Starknet contract, right? And of course, interfaces are traits. So this is how you define your interface by adding this annotation here. Now, this is the most important part that we need to pay attention to. Line 11, right? This is what tells your Dojo, this is what tells Dojo that this is a Dojo contract, right? This is what tells it. So this is like one of the main difference between a Dojo and a Starknet contract, right? But the syntax, as I said earlier on, the syntax is basically the same, right? So similar imports, right? Now, I want you to take note of these two guys here, right? So you have model storage and event storage. So why are we importing both model storage and event storage, right? So we're importing model storage because we want to have access to the models that we've defined earlier on, right? You know, our models are not here, they are in a different file. We want to have access to those models, and also event storage. We want to be able to create events, right, from this particular contract, right? But over here, the imports are pretty much the same, right? Same to what we're already used to. You have the interface. So this is like the same interface you have up here, direction, position. Yeah, all of these guys are like from the models, and yeah, you have some Starknet native functions and types here. So this is our first event, right? Moved. So this is how you create an event, right? In Dojo, you come and you give the event a name, right? And events, right, events also have keys. So one thing I want you to notice, events behave similar to models, right? Just like how you, with story now, right, you can query your event similarly to how you query your models, right? So that is why their definitions are similar, right? An event is also a struct, right? A struct with keys and also fields, right? All together. So in this moved event now, you can see that we have only one key. And another thing I want you to notice, you cannot have an event, right, where all of the fields are keys, right? Yeah, your event can have multiple keys, that's true, but you must have at least one field that is not a key in that event. So just take note of that. So now this is where all of the functions are defined, right? You know, we already created the function type here, right? We're in the interface. So over here we want to implement those functions, right, that we created earlier on. So similarly to your Starknet contracts, right, you have an implementation, right, that implements an action and takes in a contract state. So a lot of the things are similar, right? Now the first thing that I want you to look at is this particular line 32, which is world.default. This is like an internal function we're calling. So let's check what this function is about. So basically, right, what this particular world.default function, this particular function is doing for you is getting that world instance, right? In Dojo, there's what we call namespace. So what it means is the resources of your world, right, are being saved under this namespace, Dojo starter. That's why I said you should pay attention to this Dojo starter. So if you change this particular name to something else, right, what it means is you are going to effect that all over your project. So it's like a namespace. It's a namespace actually, right? And when we get to the part of permissions, where you have to give your certain system or actions permission to alter certain models, right? You'll see where this namespace comes in handy. But for now, just know that this particular function here, this particular method in this case, is trying to retrieve this namespace, this is our project namespace, from the world. And another thing you should notice, this world, this is it. So what you should notice, this world storage, because this is a world storage type. Now this world storage gives us access to that world API I was talking about, right? And in the API I talked about some methods that you use in the world API, which is the read. Can anyone remind me of the rest? Read model, right? Right what? So what's the last one? What? Now I talked about three methods from the Word API that you mostly use. Talked about read model, write model. Updates, write is similar to updates. It does basically the same thing. So what's the last one? Yeah, correct. Emit events. You have read model, write model, and emit event. So that is what this guy gives you access to, right? That is what. So when you call self.word default, it returns a word storage instance, right? It returns a word storage instance, and that instance, right, is an instance on this particular namespace. So basically, just think of it this way as you getting access to your world. Yeah, in simple terms, this particular line is you getting access to your Dojo world, your Dojo contract. So over here we're getting the player address. Now this is a very important part I want us to pay attention to. Right, over here you can see that we are reading a model named, we are reading, okay, we call word.read model on passed in player, and player is a contract address, right? Are we together? But if you notice, we have we created a variable called position and set its type to be of position. So you might ask yourself, okay, we are reading a model, we are reading a model, right? But which model are we reading from? Because of course from here you can see that we're just passing a player, the player variable, which is a contract address, right? But which model are we reading from? Right? In the previous version of Dojo, you have to specify the model you want to read from, right? But you might ask yourself, okay, can anybody tell me, or maybe an intelligent guess on which model we're reading from? How do we know which model we are reading from? Because if you look at this word or read model, this is not only where you used it, we're also using it here. We're writing the same code, but we are getting different results. How is that possible? This one? Yeah, perfect. Because of this particular type. And if you notice, this type is a model. Right, we imported position. So if you go back to models, you'll see our position model here. Right? All together. So it knows that, okay, if it wants to store this in a position model, it should read the position model, right? It should read from the position model. All together. So this is how you read from a model. Let's say, for instance, this position model has like, okay, I said we need to add a field, but just know that if your position model has like maybe 2 keys, right, this is how you read from it. You just specify player and maybe, let's say player and which other keys? Let's say username. So assuming your models have like more than 1 key, assuming this position model, for instance, if you can see the position model, it has only 1 key. So that's why we're able to use 1 key to query it initially. But assuming it has more than 1 keys, right? This is how you query the model with more than 1 key. Altogether, you pass in a tuple with the keys arranged in the same order, right, in which the fields in the model is being arranged. Altogether, it has to be in that same order. So after reading a model, okay. So what does this mean? It means we read from the position model, right? And we want to get this particular instance, right? So what this will do is it will give us position, right, with this particular key. So as you can see, we are trying to update this model, this position model. So one thing I want to show you is, how you can add new data to your model. So by default, right? Okay, so we'll get to that shortly. I just realized I haven't told you a prerequisite to that. But let's try it on. So in line 47 here, right, this is how you write to a model. You know, I told you earlier on that most of the operation you do in your actions, right, in your Dojo system is basically read and write. Right? You read data, you manipulate it, and you write it back, you save it in the model storage. So over here, this is how you write a model. And this is how you write to a model, which means you are updating the data in a model at a particular location, right? So this is it, right? First thing you do is you create a struct, right? You create a struct with that model type, that model that you want to update, in our case now, we want to update the position model. So basically created a struct and passed in the necessary values. And if you look at our player, position model, you can see that we have player and we have vector. And this vector is a struct, right? So if you want to update this model, right, this is what you do. You create a struct of the same model type. You pass in the fields, the required fields. For instance, player now is what we passed in here. And vector, as you can see, we are creating another struct, which is a vector struct, and passing in the necessary values of the fields in that struct. So as you can see, this is for X, this is for Y. So after constructing that, we save it in a new variable, and we then save that in the model. So what will happen is, by using word.write model, because if you notice here, we're passing in the key, right? So what will happen is, using this key, right? The player is the key to our position model, right? So because you passed in the key here, it will use that key to locate that particular model in the model storage, and then update the values with whatever the other fields are. Right? Are we on the same page? Yeah. Is that clear? So what we want to do here, right, is to update a particular model, right? Is to update a particular model. So how do we do that? We want to update a model at a particular location, right, in our model storage. So how do you do that? The first thing you should get is the key, right? The key tells you where that particular model is located. Right? Just think of it like, maybe a library, just like the way you store books in library, right? Each row have name, and each book on that row has like index. So you can say maybe in this particular row, index 5, that's like the key of that book in that particular library. So it is similar to our model storage. You need the key, right, of that model at that particular location. So that is what we have here, which is the model key, and this is like the value, right, for the second field of our model. We want to update the position model, right? So basically, we'll create a struct, right, and inside this struct, we'll fill in the value, we'll fill in the fields, right, that are in the struct. So if you look at our position now, we have player and we have vec. So it means if you want to create a new struct, a new position struct, right, you need to provide player, which is a contract address. You need to provide vec, which is another struct, a vector struct. So that's exactly what we're doing here. We're creating a struct, a position struct. And the next thing we will do is to call the write model function and pass in this struct we just created. So because it is a position struct, right, what this write model function will do is it will first of all locate that position model, right? And the next thing is it will use the key you passed into the struct to locate the key, right, of this particular model in the model storage, and then update it with whatever field you pass in. So this is how you write to a model. All right, but the most important thing here is the key, right? So is there any question about writing to a model? Yeah, what is the question?
I see that the set of everything are open.
Yeah.
But But are you edit the code?
Definitely, this is like a basic, this is a very basic layout of a Dojo project. You are so is there any question?
You didn't mention of cartridge.
Yeah, cartridge.
You have to do on chain that you need to get something from the games. Yeah.
Okay, you're talking about controller.
Yeah.
Cartridge, controller.
Yeah,
so what's your question?
Can you fund the wallet address in the cartridge?
Yeah, you can find your controller. Your controller address is like, though we'll talk about that when we get to front end, but your controller address is like a regular wallet that you can send money from and you send money to. That you can send tokens from and to, right? So with your controller address, you can send either USDT, USDC, Stark, whatever tokens you want, send it into your wallet, then you can send it out of your controller wallet as well.
Because there's one thing that wanted to do one of my guys say that he transferred to Stark.
Yeah.
That is controller address and it's not of my anymore.
Okay, how do you know it didn't get to the controller wallet?
He said he went to see it.
So did he check OnChain? Did he check Starknet? No, he didn't check. As long if he sends it truly to his controller address, because you know this thing about controller is like, you know, when you want to sign up on controller, you enter a username, right? Now that username, right, under the hood, an account is being created for you, right? So that account, right, has its own address, just like the regular wallet address that you know. So it's like your username is tied to an address. So if you check the address on chain, on mainnet or testnet, you should be able to see your balance. And also, there's an easier way you can even do that. If you're from the perspective of a builder now, right? In your front end, you can use the controller inventory feature, right, to activate that token balances. So what it means is people can be able to see their token balances right from within your game. They don't need to go and check either a Starknet to see the balances of their controller. They can see it from within your game, right? You can do that with controller. You're welcome. So is anybody having any more question about what we're currently working on? No question? So we're good. So the last thing we did was to write to the position model. So this is also similar, right? We want to write to the moves model, but if you look at the moves model now, the moves model has only one key, and it has 3 other fields, right? So at this point, we want to write to the moves model. Now you can see that you can see how we are constructing the values, right, of this struct. We're constructing the fields of this struct. The first is remaining. We set the value. The next field is an option field, so we set it to none, and the last one is it's a boolean, right, where we set it to true. And as you can see, we are also using the same key, which is the player address, right? So what this means is, even if you use another key, right, it will still like. Now, one thing you need to note is when you try to update your model storage, right? Let's say you want to update the moves model, for instance. If that model has not been created before, right? Calling word.write model will automatically create that model for you, right? And if it has been created before, it will update it, right? Are we together? So that is why we don't need to manually create any model. You can see we can just come and call word.write model and easily write to any keys or any of the models, right? The reason is because using this write model method creates that model for you if it has not been created. So similarly, yeah, we created a struct that is of type moves, and we call what the write model to update the model, right? The moves model at this player position. Now player is a contract address, so we want to update the model, whichever moves model that is at this player address, that is located at this player address. So that is it for the move method. Let's talk about that is it for the spawn. Now this spawn, the idea of this spawn method is to create a new player, right? You know, whenever a player visits your game for the first time, you need to create a model for them, right, where their activities can be stored. Maybe the number of games played, the total points they've accumulated with time. So that's like an equivalent of what this spawn method is doing. The next one is the move method, and besides this particular project we're looking at is a very basic bare bones game, right? You know, in every game you have to spawn players, right? Yeah, I mean, players have to like select their username or maybe address. That's like super important. And move, right? Move is like in an action game, you know, you move to the left, move to whichever direction you want. So whenever you call move, assume where your front end, now whenever you call move from your front end, either you move left, right, forward, backward, this is the guy that gets called, right? So let's quickly look at the move method. The first thing we're doing here is to get the world, is to get our world instance, right, from world.default, which is a function we created. Now the next thing is to get the caller address, which is like what we want to use as our key, right? Now we are reading from this model, position model, by passing in this player address. So you can see that over here we are reading from we are trying to read a model from our world, right? But we're passing the same values, we're passing the same keys that will be used to read from the model, right? If you notice, this is where the difference is, right? Over here we are reading from the position model, and over here we are reading from the moves model. Let me check something. So the first example we saw, right, in this spawn method is how you create a new data, right, in your model, right? But in this move method now, we will see how we can update existing data in the model by using the keys. I want to get that. So the first thing we did was to get the first thing we did was to get model at the models at various position, right? In our case now, in the position model, we want to get the model at this particular player. Okay, the names are conflicting, right? But just know that we want to get from the position model, we want to get a particular model with a key of player, and similarly from the moves model, we want to get a particular model with a key of player, which in this case is the contract address. So this is like a pre-check, right? In the moves you want to check. Now, this moves model, right? Since it's a type of moves, it means we can have access to the fields directly from our contract. So altogether, if you go back to moves now, right, has a field called can move. So whenever you get access to this particular moves model, whichever instance of the model you get access to, you can also access the fields of the model as well. So over here we're checking the can move field. Now the next thing we are doing is we are updating a field in a particular model instance. So over here we got our model instance, and the next thing we are doing is we are updating a field, right? The moves model has a field named remaining. So this particular model instance that we got, we are trying to deduct 1 from the remaining. Remaining is, I think, is a U8. So we are trying to deduct 1. What it means is we are trying to update this particular model. So we are also setting the last direction here in this model instance. And next position is just a function created over here that gives you that gives the next position, right? By taking the position and the last direction. So the most important thing I want you to pay attention to here is, you can see after assigning a new value to the last direction, right? Over here in line 90, we are updating the model. So what it means is we got a particular model instance, right, at this player. So using this player key, we got that model instance, and over here we updated one field. Over here we updated another field, right, all together. And after updating this field, we now write that new update into our model. So that's how you basically write to the model. You can't write it directly. You have to write like a copy of it. So one new thing I want to show you guys here is event. So if you notice up here, we created an event called the moved event, right? So this moved event now, right, this is how you emit this moved event. You call the word.emit event moved, and you pass in the fields, right? You pass in the values of those fields, right? In our case now, moved event has player and direction field. So what does that mean? It means in order to emit this moved event, you have to pass in both the player and the direction field. You have to pass in the values for those fields. So are we together? Is there any question? Now this is just like a bare bones game, right? So with this particular, this is just like, I would say, a layout or something very simple. So with this particular example now, right, you can build whichever games you want. So those backend logic, right, that you normally write in either Python, either Java, JavaScript, right, in a regular game. So this is where, and this is how you write to those. This is how you write those logic, right? Just like how you access specific schema or collection from your backend API, right? And you modify those schema or collection. That is similar to what we're doing here. We're accessing models we are modifying those models. Right? We're accessing models at a particular key, and we are modifying those models. So these operations are like similar to what you're used to, but just some little difference that we've highlighted. So is there any question? Let me see if there's anything I didn't cover. But if there's any question, you can just let me know. Okay, so let's move on to build this particular project. So in order to build your Dojo project, right, you need Sozo. So Sozo comes when you run Dojo up, comes with the other set of tools, right? And the command to do that is Sozo. You use Sozo build to build your Dojo project. Now, this will generate the necessary artifacts, right, that you need in order to deploy or migrate this particular project. So as you can see, my build was successful. What does that mean? It means there's no error in my contract, there's no error in my models, and everything was successful. So after building our Dojo project, right, the next thing to do is to run the test. But let me quickly open this test. So before we open the test, right, let me first of all show you how to run the test. So in order to run the test in your Dojo project, you use the command Sozo test. So what Sozo test will do, right? Sozo test will essentially run all of the tests in your Dojo project, right? It will run all of the tests in your Dojo project. Now, this is so let's see how we can write and modify these tests. But before I talk about tests, right, I want us to talk about something else, right? I want you to be aware of, permissions and, deployment process, because all of those stuffs are being covered in the test. So it's better you understand how Dojo permissions, configurations, and all of those things work. Okay, so what we want to do now, right, is to use Katana. And what do we want to use it for? We want to deploy this particular project to Katana locally. So it is similar to how you deploy your Starknet contract, either to testnet or mainnet, right? But in this case, it is being deployed locally. So I'm going to split my terminal. Close this. So in order to spin up Katana, right, you can just run the command Katana. But this particular default Katana is usually not enough. especially if you want to connect your front end to Katana, you need to add some other configs, right? So let me quickly pull up that command. Yeah. So you need to add the necessary flags and, okay, let me. So these is how you run Katana in dev mode, right? Type Katana, you set it in dev mode, and you also add this no fee flag. And this particular, so why are we adding this here? We're saying, okay, Katana should be able to be accessed from any origin, which means that including your front end can access Katana. Because when you start integrating front end to this your Dojo project, you need your front end to access Katana, right? Read from Katana, get access to the account that was created from Katana. So that's why we're adding that. So we'll run Katana, and so after running Katana locally, right, as I said earlier on, this is like Starknet blockchain, but running locally. The Starknet sequencer specifically running locally in your machine. So what does this give us access to? This gives us access to deploying our Dojo contract, right? All together. So this gives us the power to deploy our Dojo contract locally. So in order to do that, you can simply use the, I don't want to use the shortcut, but if you come over here, by default, right, it comes with some scab. So, okay, let me talk about this script before I proceed. So you can actually add script, right, you can actually utilize script in your Dojo project. What does that mean? It means instead of typing some long exhaustive commands, you can just basically, save those commands here, and if you want to run any of your scripts, you can just use scab run migrate. In this case, we are running the migrate script. So in the case of spanner, you can see that this is a super long command to run. And we don't want to be typing this command every time we want to spawn. So you can just simply use scab run spawn. So it will run whatever command is in this particular script section. So now that Katana is running, the next thing to do is to migrate our contract. So how can we do that? We can simply do that by running sudo So as you can see, Sudo is helping us deploy our contract, and it's helping us syncing permissions, it's helping us doing a lot of stuff, right? This migrate command that we just ran is far beyond just deploying your contract. Sudo helps you do a lot of stuff on that hood, like registering your models and permissions and a couple of other stuffs. So as you can see, right, our contract has been deployed, our Dojo world, or whatever you want to call it, has been deployed, and it was deployed to this particular address, right? So what it means is we can access this our Dojo world, right, from Katana, right, using this address. And of course, Katana comes with some account, right, some pre-deployed contracts and accounts. So look at it. So Katana gives you like, I think 10 pre-funded accounts that you can use to experiment while building locally. The reason is because you can't, at this point, I don't know if the update has been implemented yet, but you can't really use your normal wallets, like maybe your Argent or Bravos wallet, to interact with Katana. You can't. So that's why Katana comes with some pre-funded accounts with both address and private key that you can use to interact with Katana as a signer. So now that we have this, now that we've deployed our contract to Katana, right? The next thing we want to do is to start indexing this our Dojo contract or our Dojo world, such that whenever any state change happen, right, we'll be able to keep track of that and display it to the front end or notify our players something has happened, maybe a new player joins the game or something like that, right? And in order to index your Dojo world or your Dojo contract, you'll need Tori, right? So Tori also comes pre-installed with when you run Dojo up, right? Tori also gets installed in your terminal. So let's do Tori. Check this earlier on, but just to verify, we have Tori 1.4.2. So you also need some flags, right, in order to, so you also need this word flag passing the word address, and you also allow access from all origin. So the reason is because your front end, right, your front end needs access to the data Tori is indexing, and your client, in this case, needs access to the data. So that's why you need to allow access, cross access from all origins. So we'll just replace this with our word address, and I'll be sharing this particular resource after the class, so we can all have access to it. So copy the word address and you paste it here. So as you can see, right, Tori is now indexing all of the data in our world. So what this means is any state change, right, that happens, right, nothing else. Yeah.
Now, what's the deployment? Is it to which of the net?
Locally.
Okay, your local machine.
Yeah, it's not available outside your machine.
So how can people access the?
Okay, so we'll get to that point, right? And in order to do that, we'll use slots.
Okay.
We'll use slots to create a Katana instance and a Tori instance that can be accessed outside your local machine. And also, when you deploy to testnet, when you deploy to Sepolia, it can also be accessed outside your machine. And mainnet as well.
Once you are updating the content of like instantly, like let's say when we are calculating number of rooms, I'm using WebSockets to fetch from the index device.
Yeah. Dojo.js comes bundled with a lot of that for you. So you don't even need to configure the WebSocket yourself. When we talk about Dojo.js, you'll notice how easy it is. Right? Dojo.js has simplified all of those processes for you. So automatically it will open a WebSocket that will listen for events that are emitted from Tori and update the client when necessary. So one thing I want to show you here is is your various profiles. You know, earlier on we talked about Dojo being a profile-based system, right? So what it means is you can run your project on different profiles, right? So by default, it uses the dev profile, right? But you can run it on the release, or if you want to add new profile, let's say you want to deploy your project to mainnet or testnet, for instance. Are we together? You just simply create a new profile here. And you copy whatever you have in your development profile, but you simply change the RPC URL. And all of these guys, if it's testnet or mainnet, you're not supposed to have your private key and your account here. And also, you just change the seed, because when you deploy, right, to either testnet or deploy to Tori, right? Sometimes, because this seed, right, is what makes your deployment unique, right? So sometimes if you choose a seed, that seed might have been taken by somebody else. So you just change it to a more unique seed. So also, this is where you specify the namespace. In our case, Dojo starter. So I'm talking about profile now, right? So if you want to deploy this to Sepolia, you just change this to cartridge Sepolia. You can get this RPC from here. No. You can get it from here. Yeah. So if you want to deploy to mainnet, similarly, you just create a mainnet profile. Oh, sorry, I misspelled that. Dojo mainnet. There's already Sepolia. So you duplicate similar profile information, but you just change the RPC, and also you don't include your account address. So please note that you don't include this, like I'm saying it for the second time. You should not include your private key. This is just for demonstration purposes, right? If you want to deploy to either Sepolia or mainnet, you need to create an environment variable for that, but we'll talk about that later on. Yeah, so you just change this to cartridge mainnet RPC, and you also take note of the seed. If it's already taken, you create a new seed, right? Are we together? Are we together? Yeah, I'm with you.
So now, speaking from the back end perspective, Node.js and SOS, if you are putting your access to your private key in an environment variable, any platform you are deploying to, you can put it there.
No, in this case, right, you will not put it in. Okay, so if you want to deploy to either testnet or mainnet, you have to do it from your computer, right? So you are not like deploying it in a cloud, or you are not like submitting your private key to anywhere. You'll have to do it.
You not put it in the
Yes, you should not put it here, right? So what you do typically, right? You create a file named I think env. So mainnet or testnet. Now you add this file, though I'll maybe later on we'll talk about, I'll show you how to deploy on either testnet or mainnet, but just know that when that time comes, right, you need to create an environment variable .env.mainnet, yeah, or .env.testnet, and then you come to git ignore, you add it. You add it here to make sure that you don't push it whenever you push this code to a version control like GitHub. And secondly, you create a deployment script, right? You create a deployment script. Right, so you create the script, also add it inside .env. Sorry, .gitignore, I mean. Deploy. So after doing all this, right, you get the deployment script. You can get the deployment script from here. Right, all together. So once you get the deployment script, I think this is Sepolia, so you replace whatever part of it that is not, you just replace it with mainnet if you are deploying to mainnet, or if you are deploying to Sepolia, you leave it like that. And you come to your terminal and you run this particular script. You run source. Yeah. So that is how you deploy it to either testnet or mainnet, right? So it means your keys, right, your private key and your account that you use for deployment are all locally on your computer. It is not in a cloud or it's not in another environment, and it's not even pushed to a version control. So are we together? Are we together? So one thing I want to show you, right? One other thing I want to show you is how to deploy using slot, right? We've learned how to deploy your Dojo contract, right, locally. So the next thing we want to talk about is how you can deploy using slot. Now slot is like your, let's say, that guy that comes to save you from local development, right? Such that when you're done developing your code locally, you can share it with friends and family to preview your game, right? So that is where slot comes in. And slot is also used in production environment as well. So let's deploy now. No, okay, slot is like, you don't have to deploy. Okay, these are like different environments, right? Mainnet is a different environment. Testnet, Sepolia is a different environment. Slot is a different environment on its own as well. That's why we have profiles, different profile. In our case now, this profile we just deploy to our local environment is a dev profile, right? So if you want to deploy to slot, you most likely use the release profile, right? And if you want to deploy to Sepolia, use the Sepolia profile. If you want to deploy to mainnet, use the mainnet profile.
But just mention that if you want that your friends are coming, test your game, what is running, I use those source for it. So how can they access the game without source?
No, you can use slot. I say slot.
How can they access the game?
Without slot.
just the mention of
Yeah.
that your database can test your game.
Yeah.
So how can they access the game without deploying the game first?
No, they have to deploy it. We're about to do. Like, I want to show you how you can deploy it to slots.
Okay.
Yes. I want to show you how you can deploy it to slots. So you can get access to an RPC URL and a Tori URL. So let's stop this. Now, in order to deploy to slot, the first thing to do is you have to install slot because slot doesn't come with Dojo up. So you can go to the slot documentation. Let me see. I think I can get access to it from here. So you can go to the slot documentation and follow the installation guide, right? It's super easy, right, to install slot. Just copy this command and paste it in your terminal, right? And when it's done executing, you have slot installed. Now the next thing to do is to log in, is to set up your slot out, because you know when you deploy, when you deploy your Tori and your Katana instance, you will need an account to do that, right? You will need a controller account to do that, right? And it is at this point, right, that you authorize your controller account to be used for deploying both Tori and Katana instance. So let's do that shortly. Let me use slots out login. So I already have slot installed, but if you don't have it installed, just copy this command, paste it, and then you type slot up, right? Slot up. I don't know, it's not included here, but I think after running this command, you need to still type in slot up. I think so. Let me see. Let me check the Dojo documentation on that. Probably it has changed. Yeah, you need to type in slot up. You need to run slot up after installing it in order to get access to slot. So I already have that. So what I'm going to do is to simply copy this command. So this is how you create a Katana deployment, right? You know, just like how you run, just like how we run our Katana locally, and you know, when we run our Katana locally, we had access to it, right? Did I talk about that? You know, if you run your Katana, you get like, this is now running. You'll be able to access your Katana, right, from port 5050 on your local host. Okay, it didn't, okay, yeah, this is it. So it says RPC server started at localhost at port 5050, right? So it opens a new, this is like a server, right, an RPC server that can be accessed in your localhost at port 5050, right? So when you deploy a Katana instance using slot, it's like you, right, you running this particular instance, right? But not on your local machine, but in the cloud. Altogether, but in cartridge infrastructure. So they give you a link that you can use. So instead of localhost 5050, you get a link that you can use to access that Katana deployment. So what it means is your front end can access that your Katana instance from anywhere, not only on localhost. So let me stop this, clear my terminal, and create a slot deployment, a Katana deployment using slots. But before then, let me log in. So before you use Katana to do anything, you first have to log in into your controller. So just gonna create a new controller. Yeah, this is, so I'm just going to log in into my existing controller. I don't need to create a new one. Yeah, so what it means is I've successfully logged in. Okay, approve. Yeah, so you need to actually approve in order to have access to slot locally. So as you can see, I now have access to slots, right, locally from using my controller account. Do we understand that? It's like an it's like an authentication method, right, for accessing slots. But in this case, I'm using my controller account to authenticate my access to slots. So there's a successful message. I'm now logged in, and so the next thing we are going to do is to create a Katana deployment. So in this case, let me name it, it has to be a unique name, because if you use a name that has already been claimed, you'll get an error. So let me see, what's the name of this project? My first Dojo game. Let me just call it 99. My first Dojo game. So Slot is creating a Katana deployment for me. So the deployment was successful. So what it means is I now have access to a Katana instance running in the cloud, running in cartridge infrastructure, right? So it means my front end can now connect to a Katana instance from anywhere, any client. It means anybody can now get access to our contract deployed to Katana. So the next thing we are going to do now, right, is to deploy our contract to this Katana instance that was created for us. Altogether, you know, initially we ran Katana locally, and we deployed our Dojo contract to that local Katana, right? But in this case, we are no longer running Katana locally. We want to use the one in the cloud. So we need to deploy our contract to this Katana instance in the cloud once more. So how can you do that, right? So this is how you can do that. Simply copy this link, right? The link to your Katana instance, and come over to release. Yeah, come over to release, and so as you can see, I replaced that with my Katana URL. Altogether, As you can see, the Katana deployment that I just created now, right, is what I used to replace the RPC URL over here. Right, all together. So the next thing to do, right, now if you notice, when we ran Sozo migrate initially to deploy our Dojo contracts, we didn't specify any profile. And as I said earlier on, the default profile is dev. So if you just run Sozo migrate, it will use the dev profile. But now we want to use the release profile, right? How do we do that? We add the release tag. We specify that we want to use the release profile, right? So let's do that. Okay, I've not built. Okay, I was trying to use a shortcut. Probably it's not available yet. So let's try this Sozo migrate. Okay, the first thing to do, right, is to actually build. We've not built this project, we need to build it first. So are we together at this point? So after building this project, right, after building this project using the release profile, the next thing to do is to deploy, right, using the release profile, is to migrate, right, which deploys the contract for us. So how do we do that? It's very similar. Just run Sozo So are we together? Can you see what's happening here? You can see that this particular deployment, right, this particular migration is being carried out on this RPC URL, as opposed to localhost when we were deploying when we were running the migration on our dev profile, which was on localhost. But in this case, it's happening on this particular RPC URL. So this will deploy our contract, right, to slot, and it will give us a world address, a contract address, right, that we can then use Tori to index. So deployment was successful and we got this particular world address. So just to like remind you, right, in this case where we are using a Katana, a slot deployment, right, in your RPC URL, in your front end, right, maybe in your client, right, you need to specify, you need to replace, if you're using localhost initially, right, you need to replace that localhost URL with this particular RPC URL, right, because your client, right, will be looking forward to a URL other than localhost, in the case of where you want to like share it with friends and maybe outside your machine basically. So replace your RPC URL, the RPC URL from your client with this one, right? And let me see. So after deploying our Dojo world, and getting this address. The next thing to do is to create a Tori instance on slot altogether. So the command is similar. It's a similar command, but in this case, we have to specify the world address. And the world address is what we got from here. So let's just replace that with. And now the project name, similar to when we were deploying a Katana instance, right? We also need a unique project name, right? We also need a unique project name for this. So let's call it, let's give it a similar name. Let's call it my first Dojo. Is it Dojo? My first Dojo game 99. Now, one last thing we have to specify here is which RPC URL, but let me see. So let me see how we can specify the RPC URL, because since this is a custom RPC URL, unlike when we were deploying it locally, we didn't specify an RPC URL because it looks at it already knows the default local Katana RPC URL. But let me quickly check that. Okay, it was not specified over here. Well, let's see. Let's try this out and see. Since we already know our RPC URL, right? Okay, RPC, it's supposed to be RPC. Yep. So what's happening now? After deploying our Dojo contract, right, to the Katana instance that was created by slots, we now want our Tori, right? We now want to create a Tori instance that will index all of the data from Katana, right? From that Katana instance we deploy. We're getting an error. Let me see, RPC error, internal description. Getting port. This error is not pretty straightforward. This is not pretty straightforward. Probably there's been an update. But let me see. Let's try this one more. Probably it could be that my slot version is outdated. So while we wait for it to deploy, is there any question at this point? Is there any question? So one opportunity that I want you all to not to like take advantage of in the Dojo ecosystem is the fact that currently you can see that a couple of stuffs are missing in the documentation, and Dojo is completely open source, right? Dojo is completely open source. So what you can do is you can go to the repo, like this particular documentation is open source. So you can go to the repository if you feel like anything is missing or anything was not added. You can just open a pull request and add that particular part that was not in the documentation. Like for instance, if you notice, there is no guide here on how to. Though this used to work, but it's taking longer than expected. So probably there's been an update, right, that maybe introduced the breaking change, and as it has not been added in the documentation. Let's see. Yeah. So this is like an opportunity you can take advantage of, right, to help fix the documentation and add whatever you think is missing. Right? Are we together? So let me see. Okay, it's not here. So what we are going to do is, let me see if this is done. It's taking longer than expected. Probably, I don't know why. Probably it's under maintenance or something similar. So we don't have to wait for this, but just know that assuming this completes, right, successfully, it will give you a link similar to what we got from deploying our Katana instance. So it will give you something similar to this, right? So what does that mean in your clients, right? You can now replace that local Tori URL with whatever you get from here, whatever you get from running it. All together, it's taking longer than expected. So what will happen is I'll try it out later, and I'll ping the cartridge team. I'll send a message to them about this, that story is taking longer than expected. So I'll send a message to them, and we'll complete this in our next class, and we'll also learn how to deploy to Sepolia, how to deploy to testnet and mainnet as well in the next class. And we'll also talk about front end, right? How, now that you've completely built your contract, how can you integrate that with front end using Dojo.js? So how can you read from your front end? How can you write from your front end. So we'll talk about all of that in our next class, but we're stopping here for today. And before we go, is there any question?
So the Dojo JS, just like Starknet JS.
Yeah, I think a couple of the things, I think it's more like your app, Starknet JS. But yeah, most of it has a lot of similarities with Starknet JS, but it just makes it convenient for you to interact with your Dojo contract. And it has all of those configuration, like most of the, you have to do some of the configuration yourself, but it comes with some of those configuration like WebSockets, so you don't have to configure WebSockets in order to listen for events that have been emitted by Tori. So is there any question before we wrap it up? Yeah, I'll drop link to the documentation after the call. So, without any question, we'll call it a day. Thank you all. See you in the next class.